Hello, this is going to be the homework help for solving a formula for a specific variable. I think I've got 3 problems marked on here we're going to do. So when given a formula, you want to be able to do a couple things with it. Either if they give you values to evaluate it, you want to go ahead and be able to do that, often with a calculator or just by hand. So on this one here, given A equals 1/2 BH, solve for H. When A equals 176 and B equals 22, and then in general. And so let's go ahead and just do this without solving for H formulaically. We'll put these numbers in. So I'm going to say 176 equals 1/2 times B, which is 22, times H. Again, I'm trying to figure out what height, this is the area of a triangle. What is the height of a triangle with an area of 176 and a base of 22? And so we got half of 22 is 11. So I'll have 176 equals 11H. I'm going to divide both sides here by 11. And we'll get H equals 16. Now, they didn't include units here, but whatever the units are here, it'll just be inches or feet or meters, whatever it is. They don't have inches. They don't have any units, so we'll just put H equals 16. So that was part A. And then part B says, well, let's just solve for H in general. So that means without these values. So let's go and rewrite the formula over here so it's near us, 1/2 BH. So again, I'm solving for this guy right here, the H. So there are 2 things over here I don't want. I need to get rid of them. And so I'm going to multiply both sides by 2. Those cancel on this side. And the left side, I'm left with 2H equals the right side, I'm just left with the BH. One more step to solve for H, divide by B. So H equals 2A over B, and we will normally write it with the formula with the variable solved for on the left. Wouldn't count off if you didn't do that. There we go. So now we have a formula for H in general. Now, why would you want to do this? Often, formulas are given for often the most solved one, the one we're often wanting to find, like the area. What's the area of a triangle, area of a square, volume of a pyramid? But occasionally we know the volume or we know the area, we know that variable that's solved for, and we want to solve for another one. And if you're only doing one problem, the A way might be the way to go. But if you're doing a bunch of these, it's nice to already have a formula. And now we have a formula for the H, given the area of a triangle and its base. Okay, a couple more here. Solve with formula. We have 3x plus 2y equals 11. Solve for y. We're sort of foreshadowing what we're going to be doing in the next unit, looking at equations of lines. And we do this all the time. So while we're in this section on formulas, we'll just call this formula. This is an equation of a line. And solve for y. So what do we have here? I've got 2 things over here I don't want. I've got this 3x and a 2. I need to move them both. Now, it's typically easier to remove this 3x first. So I will subtract 3x from both sides. So bring down your 2y. These cancel. Equals. Now, I'm going to slide this 3x in here, negative 3x in first. And you'll see why in the next unit. It'll just feel a little better that way. Now divide through by 2. Now we actually have a couple options here. I'm definitely good in this section if we can be done right there. We can say y equals negative 3x plus 11 over 2. You could have said 11 minus 3x over 2, and I'm fine. 100 full marks on that one. So this is definitely a good answer. However, another way to write this is to go ahead and divide the 2 into both of these. Now, it doesn't seem to bias a whole lot of information here because my fraction doesn't reduce. Sometimes that fraction will actually reduce. But these numbers here, the number beside the x and this constant term will have some special meaning in the next unit. And so it's just sort of good to see how that can be done at this stage so we're not wrestling with too many concepts in the next unit. In fact, this number here is the slope, and this is the y-intercept of the equation of the line. And we'll learn that in the next unit. Okay, one more here. So this is the perimeter of a rectangle, given the length and the width. So just sort of imagine if I've got a rectangle here, I'm given some length and some width. It doesn't matter which one's a length, which one's a width. and we want to solve for the width. Maybe we know the perimeter and we know the length. We know, well, what width do I need to have in order to have a perimeter, a certain perimeter, and a certain length. So let's go ahead and do it. Solve for W. So I've got two things over here I don't want. I've got this 2W, and I've got a 2. So I'm going to subtract 2L from both sides. I may have said 2W, I meant 2L. Subtract 2L. So the left side is just P minus 2L. I cannot combine those. They're not like terms, right? Equals. What's on the right side? Well, these canceled, so I'm just left with the 2W. Now, one more step. I've got to solve for W, divide by 2. And so I'll generally, again, write that variable solving for on the left. So W equals, we can say P minus 2L all over 2. So that is a perfectly good answer. Another way we could have done this is we could have said W equals, we can divide 2 into each of these. P over 2 minus 2L over 2. Now, when I do 2L over 2, what happens? Those 2's cancel, and I'm just left with an L. So both of these have their sort of distinct advantages. It doesn't matter to me, generally, which way you write them. I'll be honest, if I were you, I would just write it this way, the first way, because it's very tempting to make a mistake when canceling. What some students do, don't let this be you, is they will cancel these 2's out. It's pretty tempting, but don't do that. We can only cancel factors, and this 2 is not a factor of this term up here, because I'm dividing 2 into each term. So just be careful on that. All right. Well, I know this is a hard lesson on formulas. It's very similar to when we just had one variable solving for x. We use those same principles when solving a 4-bit variable when we have multiple variables. So I hope that helps.